So hi there folks. So in this video, we're going to talk about more in the fundamentals of mathematics, and particularly we're going to start with our topic in the rules in divisibility. So first off, there are three, this topic rules in divisibility will be divided into three parts. So first batch of rules, second batch of rules, and third batch of rules. So specifically, we're going to start with the first batch of rules here. So again, recall what divisibility is. Divisibility is when you say that when you divide a number by this number, it will end up, the quotient will be still a counting number or a whole number. So a divisibility rule is actually a shorthand of determining whether an integer is divisible by a fixed divisor without performing the division itself. Okay, so to know if it is divisible or not without even performing the division. So they're like automatic tricks in our mind. Okay, so that we can automatically know that yes, this is divisible by this number because of these rules. Okay, so it is usually done by just examining or investigating the digits themselves. Although there are divisibility tests for numbers in any radix or base, radix is just a base, and they are all different. This video presents rules and examples only for the decimal or the Hindu-Arabic, or shall we say base 10 numbers, base 10. So who's the one who really started it all? It was Martin Gardner. He explained and popularized these rules in his September 1962 Mathematical Games column in the Scientific American Journal. Or is it a newspaper? Okay, so let's start. Again, this is just the first batch of divisibility rules, okay? First up in our list is the divisor. What if the divisor is 2? How can you easily say that this number, this particular number, is divisible by 2? So what is our condition? Condition is simply said if the last digit is even. Okay, so if the last digit is even, the ones digit, the units digit specifically is even, say that is 0, 2, 4, 6, and 8, it is divisible by 2. Okay, it is divisible by 2. And as you can recall, that's the main reason why it's called even numbers, because yeah, they are divisible by 2. So examples, 8764, 8764. We don't need to really look at the other numbers, the tens place, the hundreds place, thousand place. Just look at the ones digit. It's 4, so therefore it's divisible by 2. We have 987,760. Okay, 987,760. Just look at the last digit. It's 0. That's even. Therefore, it's divisible by 2. We have 2,342. Again, the last digit is still 2. That's still even. So therefore, they are all divisible by 2. Okay, so let's have some quick exercise. I think you can answer this very quickly. Are the following integers divisible by 2? So we have 1, 2, 3, 4, and 5. I think I can just, yeah, you can just watch it now and answer. And I believe you also have the answer already. How about number 1? Is it divisible by 2 or yes? 2 or no, rather. So the answer is yes, because it's 0 here and it's an even number. How about number 2? Uh, Practically that's a no because 1 is not even. How about number 3? Also a no, that's not even. 3 is not even, it's not found in this list. 8, yes, that's even, so that's divisible by 2. And number 5, you just only look at the units digit. Yes, it is. So that's how simply we know if one number is divisible by 2. Just look at the ones digit, and if it is even, so therefore it's divisible by 2. Okay? Now let's add up to that divisibility rule, and then we're going to put up the 3. Okay, here you go. Now, if I'm given a one particular number, how do I know if it is divisible by 3? Here's the rule. If the sum of the digits are divisible by 3, the sum of the individual digits, okay, the digits in any place number, okay, if the sum is divisible by 3, it is, the number itself is divisible by 3. For example, we have 405. What we need to do is add all the digits, okay, all added all digits. So we have 4 plus 0 plus 5, it's equal to 9, and we know 9 is divisible by 3, therefore 405 is also divisible by 3. Okay, another example, so we have 636. So it's really kind of long if we're going to have the solutions themselves, and it will be quite tasky. Just add them. 6 plus 3, it's 9. 9 plus 6 is 15. So therefore, is 15 divisible by 3? Yes, it is. Okay, it's 3 times 5 specifically. So therefore, this number, 636, is also divisible by 3. Okay, so next batch of exercises are the following integers divisible by 3. So maybe you can pause the video and try to answer yourselves. Okay, so I believe you have the answer now. So for number 1, what we need to do is to add all the digits. 2 plus 6 plus 4 plus 0. So 2 plus 6 is 8. 8 plus 4 is 12. Now the question is 12 divisible by 3? Yes, it is. Okay, it is 3 times 4. It is 3 times 4. How about number 2? 57,621. So is it divisible by 3? Let's check it out. 5 plus 7 is 12. 12 plus 6 is 18. 18 plus 2, that's 20. 20 plus 1, that's 21. Is 21 divisible by 3? Yes, it is. Okay, how come? Um, try 7 times 3. That's 21. And how about number 3? So we have 8 plus 9, that's 17. 17 plus 5, that's 22, plus 0, plus 3, that's going to give us 25. Is 25 divisible by 3? Nah. So therefore, this number, 89,503, is not also divisible by 3. Okay, so that's our rules for divisibility of 3. Okay, we're going to add up with our table there, and we're going to add more divisibility by 4. So yeah, it's quite there's a lot, sir. Can you do this slowly? Yes, I will. Actually, all these bullets here are ways of determining if the number is divisible by 4. Okay, first, the last two digits form a number that is divisible by 4. The last two digits. So meaning we can let go of the other digits, the hundreds place, the thousands place, if and only if we want to know if it's divisible by 4. We only need to put in our focus with the last two digits, the hundredths place and the units place, or the ones place. So if it is divisible by 4, so therefore it is divisible by 4. For example, we have 40,832. We will only look at the 32. Is 32 divisible by 4? Yes, it is. Yes, it is. Next, if the last, or rather, if the 10 digits is even, the 10th digit is even, the ones digit must only be 0, 4, and 8. Okay? If the 10th digit is even, the ones digit must be 0, 4, and 8. And let's try here. 72,728, the 10th digit is 2, so therefore it's even. Let's try if it is 0, 4, 8, and it is 8. So actually, you can look at this, 28. So using the rule number 1 here in the divisor of 4, it still happens. It still follows that it is divisible by 4. Okay, number 3, it's the opposite of number 2. If the 10th digit is odd, the ones digit must be 2 or 6 only. 2 or 6. So for example, 40,832. 3 is odd, and our ones digit is 2, which is one of on the list. So therefore, this is divisible by 4. This is divisible by 4. Also we have here twice the 10th digit. This is the computational part. Twice the 10th digit plus the ones digit must be divisible by 4. So for example, here again we're only going to focus ourselves with the two last digits. Twice 3 is 6. 6 plus 2 is 8. And 8 is divisible by 4. Therefore, this number 40,832 is also divisible by 4. And lastly, if the last two digits are both 0, okay, if the last two digits are both 0, it is divisible by 4. It is divisible by 4. So for example, 12,300, yes, it is divisible by 4. So I think it's your time to have some exercise very quickly. So we have 1, 2, 3, 4. Determine if they are divisible by 4. Go. Okay, I hope that that's enough already. So what rule would you like to use in number 1? Actually, we can apply any rules here, but the simplest is the first. Just look at the last two numbers. If they're divisible by 4, so therefore it is. Is 40 divisible by 4? Yes, indeed. It's 4 times 10. So it's divisible by 4. Or 40 divided by 10 is 4. Now, let's have it here. 57,621. Is 21 divisible by 4? No, no, it's not. And we can check it here in our rule number 2. The tens digit is even. Is it 0, 4, or 8? No, it's not 0, 4, or 8. It's 1. So therefore, yeah, we can see that it is not um, divisible by 4. Next, let's try number 4 rather. Twice the tens digit. Twice 2 is 5, is 4 rather. Twice 2 is 4. Plus the ones digit, which is 1. So 4 plus 1 is 5. Still not divisible by 4. So as you can see, there's a lot of ways to know if a number is divisible by 4. One just needs to have some exercises with them. And number 3, 89,503, is this divisible by 4? Just look at that last two numbers, 0, 3. So it is not. It is not. And we can again follow the same rules here. So for example, 0 is even, so that's even for the tens digit. So it is not 0, it is not 4, it is not 8 because it's 3. So therefore it's not. Okay, and lastly in this video, we're going to tackle about the last rule in this first set. So what we have here is the number 5. Number 5 is the easiest so far, alongside with a 10. Okay, so if the last two digits is if the last digit rather only the last digit, that is the ones digit or the units digit, if it is 0 or 5, it is no question about it, it will be divisible by 5. For example, if you want it 495, it ends with 5, so therefore it is divisible by 5. 9860, it ends with 0, so therefore it is divisible by 5. So I think this will be the last exercises for you guys. You may try to just watch at it and know if it is divisible by 5. So it ends with 0 for number 1. Yes, it is divisible by 5. Number 2, it ends with 1. Nada. It doesn't ends with 0 or 5, so therefore it is not divisible by 5. And yeah, that's it for this video. At least we are done with the rules and dividing or divisibility. For the divisors, for example, you will have divisors for 2, 3, 4, and 5. So in the next batch of videos, we're going to present the rules and divisibility in numbers ending with 6, 7, 8, and 9. Okay, 6, 7, 8, and 9, if I'm not mistaken. Okay, those will be the numbers. Okay, so that's it for this first batch. Again, kindly subscribe to my channel so that you will be updated if the next batch will be uploaded, and don't forget to hit the like button if you have learned something here. Okay, so thank you very much for watching, and yeah, I think I'll be seeing you soon. Okay, thank you very much. Bye.